In this one, let's get a perspective of what Arima modeling is all about, a little bit of its history, when you can use Arima modeling and when you cannot use Arima modeling, and also how to understand the parameters of an Arima model. Now, Arima is one of the foundational time series forecasting techniques that has been around for quite a while now. This was first introduced by a gentleman named George Box and Gilliam Jenkins. Right? This came out in their publication back in the year 1970 in a book titled Time Series Analysis, Forecasting and Control. It has been there since then, and till today, this has been a very popular technique. And because of their names, this approach is also often simply called as the Box Jenkins approach. Now, this is a very foundational technique, and based on Arima itself, many other autoregressive techniques have also arisen. So, what happens in Arima is given a time series, what Arima does is it uses the information contained in that series itself to predict the future values of the series. And now, does that also mean that you can forecast any series with Arima? Yes, you can create forecasts, but that does not mean that they are always meaningful and accurate forecasts. Arima is suitable only to forecast those series where the past values of the series has sufficient pattern and information to predict its future values. That is, you cannot simply take something like the stock prices, you cannot simply take a stock price, use Arima model and produce a forecast and expect that forecast to be accurate and meaningful. That might not be the best way to go about it because the price of the stock price itself is controlled by multiple external factors. If those factors are not factored in the stock price data itself, then it might not be meaningful to use Arima for such an analysis. Getting it? Because the price of the stock may be dependent on certain external factors such as government regulations, price of competitors, environmental factors, weather factors, many different factors are involved. And of course, the performance of the company itself. So many different factors are involved, and it's unlikely that all this information is present within that series itself. So the bottom line is just because you have a time series data, it does not mean that you can successfully use Arima to forecast its future values accurately. That's not how it works, right? So what exactly is Arima here? A-R-I-M-A, Arima. It's a short form for something. AR stands for auto-regressive. MA stands for moving average. And I stands for integrated. So there is a parameter term for each of these. The parameter term for autoregressive is called P, moving average is called Q, and integrated it is represented using D. We will go into the details of what all of this means in very clear detail in the next upcoming video. But for now, understand that Arima is a type of time series modeling method that is not designed to model a time series that has inherent seasonality inside it. If a time series has an inherent seasonality, we do not use Arima. For explaining seasonality as well, if your time series has a seasonal component means there's a repetitive pattern at regular intervals. This pattern repeats at regular intervals. If such seasonality is present in a time series, then you use something called S Arima. S for seasonal, right? And if your series is dependent on other external factors, exogenous variables, then we use something called S Arimax. If your external factors are influencing and that series is also having seasonality, you use S Arimax. If your series is dependent only on external factors and it does not have a seasonality, then you use Arimax. X for external factors. Right, before we close, we will understand what the integrated term means here. Integrated refers to the process of making a non-stationary time series to a stationary time series, right? And the I term, which is represented by the parameter D is nothing but the number of differencing the original series has to undergo in order to become stationary. The number of differencing you need to do on a given series to make it stationary is nothing but D. After you have determined the I or the D parameter and made the series stationary, then you can do what is called an ARMA process, ARMA modeling, AR and MA modeling, which we will see next.